In this video, we're going to cover Java arrays, which you can find in the Java Basics part of the online notes. In Java, unlike in C++, arrays are objects, not primitive types, and therefore you have to explicitly allocate them using the new operator. And because they're objects and you don't know when you declare them how big they're going to be, you actually use empty braces when you declare an array. So here we're declaring an array and then assigning it a array that is 6 integers. Here the value null is actually assigned to A, and if you tried to use A at this point you would get an error because Java would tell you you were pointing to a null object. And you can see that it doesn't matter where you put the braces, you can also put them before the variable name. It also declares it as an array. So either of these two declarations declares an array. Just like in C++, you can provide a comma-separated list of values to initialize an array, and in this case it automatically allocates an array object for you. If you want to find the length of an array, you can use the length field to do so. So here c.length returns 6, and that's why you don't need to explicitly pass the length of an array to a function, since you can simply query the array for its length. And multidimensional arrays are just as they were in C++. They are arrays of arrays. So you would declare a two-dimensional array with two sets of empty braces. And then here's one way to declare that array. Or if you want to declare the individual dimensions, or in this case rows, to have different numbers of columns, I'd say this has 4 rows, and now the multidimensional arrays are just like they are in C++. They're arrays of arrays. So in this case, to declare a two-dimensional array, I use 2 empty pairs of braces, and here I'm allocating an array that is 4 by 5. And if I want the number of columns to vary, like in some matrix computations, then here I'm declaring B to have 4 rows but an undetermined number of columns, and then I'm filling in the columns 1 row at a time. And one thing that Java introduced in 1.5 is a handy for each loop that allows you to iterate through the elements of an array without using the usual for I equals 0, I less than length of the array, I++ idiom. So here you can see we have an array of integers and then our for loop, which declares a variable element on the left hand side, then a colon, and then the array to be iterated through. So on the left side the loop variable, on the right side the array, and now an element will get each element of the array in turn. So to give you an example of a program involving loops, we're going to go to the example code and look at a program, example array search. You may want to take a moment to pause the video now and just read what the problem does. I'll describe it as well. So we're writing a Java program that's just taking a list of search terms such as Brad, Nels, and James, and then it's going to take a list of terms we're searching for and determine whether they're in the initial list. And the list starts with the number of search terms. So Brad, Nels, and James, there's 3 of them, and then these are the terms we're searching for. So you can see the output, Jim is not in that list, so it's false here. Nancy is not in the list, so it's false. Brad is in this list right here, so we say true. And Nels is also in that list, so we return true. So basically, we need to write a program to first of all, find the number of search terms, then place that number of search terms into an array, and finally go through the remaining list and see whether the names in that list match any of the search terms. So here's our program. We're calling the class search. Remember, we have to embed every main into some class. And here's our main done using the Java style way, which is we simply create an instance of search and call it with our command line arguments. So the constructor is where the real action is. And the first thing we're going to do is determine the number of search terms. And you'll see that the way that you actually convert a string to an integer in Java is that there are wrapper classes. And these wrapper classes contain methods that allow us to do the conversion. So integer is the wrapper class for an int. You have double as a wrapper class for a double. Float is a wrapper class for a float, so on and so forth. Each of them has a parse method that will take a string, return an integer if it can be converted to an integer, and else it throws an exception. We'll get to exceptions in another lecture. At any rate, we are parsing that integer to get the number of search terms, and then we allocate an array of that size of strings. Then we iterate through the first n search terms in our list and assign them to search list. And notice we have to start at I plus 1 because the search terms start at location 1 in the command line arguments. Then we're going to go through each of them, each of the remaining terms, and try to find them in the search list. And you'll see that we start at n plus 1, and we use args.length as to find the length of the array. We print out the result, so find is going to return true or false depending on whether the argument is in our search list array. And you'll see this is how we can do formatted output, is with system.out.printf. And we actually have a special Boolean formatter that will print Booleans as true false, and it is %b. And finally, here's our function that goes through the array of our search terms and tries to find the key. And you can see that array declarations as a parameter are just as they are in C++. So there's obviously no size attached to the array list. We're using our special for loop construct for iterating through this list. Remember, the loop variables on the left of the colon and the array on the right-hand side. Also remember that with strings we have to use the equals method to compare two strings, and if they're equal we return true. And if we manage to iterate through the entire list without finding the string or the key, we will exit the loop. If we exit the loop, we know we failed, and so we return false.